Hello everyone, and today in this video I will talk about for each SOP node, and I will explain and I will break this node down into simple concepts so you can understand this node effectively. I will just start with a simple box, and this I will give it something like for each SOP. Inside this, we have a box. So that was a geometry container, and we have a box now, right? And I will just say for each number. So this for each number will give you all the nodes that you need, and I will primarily talk about this for each number. So you have two nodes, the block begin node and the block end node. For each begin, for each end, for each count. This is the extra node that you can create with this create metadata node, and this metadata node will tell you the data about the data. What do I mean data by data? If you have the 10 iterations, iterations here mean how many times you are repeating the same step on your geometry. So if you have 10 iterations, this will give you the iterations value 10. So when you see this is for each count. This will give you the whole data about your data. What do I mean by this? If you go at the detail level, and this works on the detail level, and if you see, we have iterations, which is 9, which is total total number of iterations, total number of repetitions you are doing on your geometry. We have num iterations, that means the total number, the total amount, the total number of iterations you are doing. These are the same thing, but here the iterations 9 means that you have iterations go from 0 to 9. So total iterations will be given by this num iterations, but the iteration number will tell you the how many iterations you do. These both are same, just the difference is that this iteration starts from 0 to goes to anywhere you want, and this num iterations will give you the total amount of iterations, total number of iterations, sorry. So just keep this in mind, that the iterations goes from n minus 1. N here is the total number of repetitions you are doing, and num iterations are the total number of repetitions. Total number of repetitions, and we have iterations. So this, and you don't need to worry about values and I value. We don't need to understand it right now, because they come when we move from intermediate to advanced. So for this video, I will just explain this. So this for each begin, I will open puref and I will say for each begin. This for each begin, for each begin will give you two things, first and second. It will give you first the feedback data. And what do I mean by feedback data? And it will say you, like you can just say fetch data. So this for each begin has two things. It can store the feedback data, and it can like input the input or output the the data, which is the what I say, the input data. It will just output the input data, and it can like fetch the data that you do after some of the setups here, and it can store that data also. What do I mean by that? You see, if you have, let's say, if you have a box, right, and you translate in x, right, by 5, you translate it in x in 5, right. this will go into this for each begin. This box will go in this for each begin, and you are saying I want to translate this, and this will be your output. This will be your output. And this box here, first, and your iterations are, let's say, 10. So the iterations value will be 9, and the uh, iteration value will be 10, right? And you have this. So what will happen? You have 10 iterations. So first you will have first iteration, and this box was here. Now it will be translated by this by 5. Now this is the new data. This was our original old data, and now this new data will be here also. So if you say feedback data, it will give you the feedback data, and if they say fetch data, then it will at every iteration will perform your function on this data, this original data. But when you say feedback data, each iteration will use the new feedback, that the new data that came from after like translating your x by 5. We will do this practically. I have transform node, right? And I'm saying I want to translate this by 5 in x. So you see our box is translated in 5, and you see our box is moving. So box data is coming into this begin node. We are just fetching the data for each iteration. For each iteration your data will be the same, right? And when you go at point level and you say 1 iterations, you will see you have second, and you have 7 points. And when you say you have 8 points, and the 0 also counts here, so your cube is made up of 8 points. So when I say I want 2 iterations, now we have 15 points. And why we have 15 points? Because you first have the gather method, and gather method is how you are gathering those those outputs that are coming after this transform node. And this transform node is saying that I just want this cube to be translated in the x-axis, right, in the x-axis by this value. And you see, when you have merged these, so each feedback will be merged into single one. What do I mean by this? I will just move it here. You see, first we have fetch input, right? That means we are working only with the original data. We are not saying that we need to fetch feedback. Feedback is result after each iteration. So when I say I want to transform this in 5, and you are saying I have 2 iterations, let's say, and I want to like merge these two feedbacks, these two final values. So when I say my object is translated, you see when I just move, let's say I can say merge, and when I merge this two, you will see we have to, this is our original data, this is our final data. So at each iteration it is using the fetch input, which is this original data. So fetch input is the original data. I will say fetch input is the original data at each iteration. So if the final thing, if the data that came from after the transform node is, let's say, it is translated in this here, we'll just use this, it is translated here. So at each iteration it is just using this same box to transform. So at each iterations, So what will happen here? I will just open pure ref. This is my first iteration, this is my zero iteration, and this is my first iteration. This is the original data, and my node says translate x5, right? So I'm saying that I just say x equals to 5, right? I want this translation. So fetch data, right? Fetch data. I will say fetch data. That means we are just using the original data. That means what will happen here, it will, at first iteration, it will move it in the x and it will be here, x equals to 5. But at second iteration, it is using that same original data and it is translating into 5. So your geometry will be at same place and these geometry will be merged. These geometry will be merged and you will see 8 points now. That's what happening with this. So you are seeing 8 points now, and when I say 2 iterations, you will see double the points. So now you have 16 points because now you have 3 boxes, right? 3 boxes on top of each other. So this is just and when you say feedback each iterations, so now you will see only 8 points because they are the like result of each iterations. So at first iteration you will see your box is just moved into x in x5, and at another like at the another iterations, at the next iteration it will also move at the same point. So you are just giving like seeing that feedback for each iterations, and when you say merged, you will see your both all of these objects are merged. It is creating new points, right? It is creating new geometry, so you don't have to like worry about this. It is creating two geometry. And when I say I want this to be, let's say, feedback, nope, I want fetch feedback. Now what does this fetch feedback mean? After this translation, when I'm saying fetch feedback, so what is happening here, when you have this fetch feedback as your this method, so what will happen, this object will be translated in x and the next iteration will work on this instead of the original data. So next iteration will be on your feedback data, and this then next iteration will be on this again. So you will box will move in x equals to 10. So at each iteration you are doing the function, like doing your translation, but on each feedback of each iterations. That's the difference between these two. And when I say I want to have these iterations, so at first iterations it will move here, it will move here, it will move here. And when you say null, and when you like when you template this, you will see that your original box is here, that your original box is not like here. Original box is moved here. This is our first feedback data, then we are doing the next iteration on that feedback data, and then another, then another, then another. So your original data is moved and then you are doing each iteration on this original data, and you are combining them. And if you say like if you say feedback each iteration, then you will only see your feedback of each iteration. Like, so where does your object move after 2 iterations? So it will just give you like your object after each iterations. So you have something like this, and you have the real example of this is it's a very cool example, and I will just, and it's in Houdini website, and it is like the cheese method to understand this. So we are doing one function, one node, we are performing one network, like you can have many steps, you can create many nodes. So what I will do, I will just create a box. I will just create a box, And this box will be something like this, right? And I will just scatter some points on this box, and I will say I want 10 points. So now this box have 10 points, and I will create a boolean operation, and I will create a sphere, and we will create some cheese, and I will say copy to points. So these are my points, this is my sphere, we have something like this. I will decrease the uniform scale, right? And I will use this and this, and now we have this, right? And when I put this, I want to do this like on this box 10 times. So what you have to do, you just have to do it again and again and again. What you can do, you can just plug this here, right? Or you can just use this. So this here is connected to this box. That means the input, the data of this box is going here. So the box lives here also. So first I'm scattering some points onto this box, and you will see we have something like this, right? And the boolean function is going here. So I will just connect it here. You see, now first we are at 0 iterations. That means we are first, let's see, we are at fetch feedback. That means we are doing each iteration on the feedback. Feedback means the data after the output data after each iterations. So when I say I want to see what first iterations is like, this means that we have a sphere scattering on points, and we are performing this boolean function on this is our first iteration, right? And we are like seeing feedback each iteration, we are not merging it, right? First we will see, look at this, then we'll see merged, see the merged data. So you have something like this, right? At 2 iterations, you see the function is performed on the feedback geometry that we got. And when I say I want to see the single pass, you will see not single pass, I will just use the merge count. You see, this is our first original geometry, and you see these circles. This is the function that is being performed on that feedback that we generated from that first iteration. And then again. So you are now scattering points on this feedback geometry, and that points is being copied to the sphere, and thus the sphere is being copied to these points, and it is performing boolean. So what you're going at, let's say after 11, 12, 13, your geometry is now gone. So you understand that we can perform like a function over and over again on a geometry, right? So this is the first method of this iteration, and when you see this merge, you will see the first part because everything is being merged, and first part has this block, but second and third iterations don't. So you will just see the first geometry also. You're just combining, right? So this is the first method of this. But what if I want to perform this function, right? I want to perform this function on 10 boxes. So I will just say copy and transform, and this copy and transform is also like we are doing some iterations, right? So the total number of copies, and I want to translate it, let's say here. So what is happening, first it is translated, then the third will be translated by this, not this. So we are doing something like this. So you understand this now. So we will go at 10, and you will see we have 10 boxes. And what I will do, I will just do the same function by this. So to do this function, you will see now, I will just do this. You see what we are doing, this is our geometry now. So this is our geometry, and this geometry is getting some points, right? Getting some points. This is our whole geometry now, not a single box, but I want to perform the same function on each boxes at each iteration. So what I can do, I can just, you have this option which is called each extract piece or point. That means we will use this we have x by piece and point, and we need to tell this which piece of this geometry is a separate piece. And for this I will just use connectivity, and this connectivity will give me a class. And if you don't know about connectivity, when I talked about this connectivity in my early videos, then you should probably go and watch it, or you should know what this connectivity do. I want this to on primitives, because when you have a geometry, you should use this connectivity when you are, doing some boolean operation or something, because when you do it on points, it doesn't work. And I can just explain it here, but I don't want to, because it's a long video now. And you have this connectivity, right? And this connectivity, I will tell this that I want these pieces by this attribute, which is connectivity. So each separate box will get a class according to their like numbers. So this one will get 0, 1, 2, 3, 4, 5, 6, 7, 8. And what I'm doing now, I just want to like say that I'm performing this on these. I have this. So you see, we have this, and I want, you can just say how many like iterations do you want, and you see we have one class, but we want primitive. So it will see primitive, and I want merge. So you see, now we are doing the same operation based on this class. So this class acting as one object, one piece of the whole geometry, and this function is being performed on each piece of this geometry. So this is another way to use this. But to make it a bit more complicated and to go in depth here, we can use this feedback count. And what do I mean by this feedback count? I will just create a geometry which will be test geo capybara, or we can use rubber toy. And this rubber toy, you see, is this piece, and I will just say add shader, right? So this rubber toy, I will say for each number, and you will see we have these 3 SOP nodes, and we understand that this is going here, and we store feedback data also here. And what I can do is I can just say color. Oh, I just want to say color. So what I want to do, I want to do on piece or a point, right? So I want to do this on primitive, right? And you can create this meta. If you delete this node, you can just create this metadata node by this this parameter. You can just toggle this on, and you will just create a node, right? And you see, now we are performing for each function on each primitive. What does that mean? I will just explain it, and you can just say random. And when you see this, what is okay, I don't want this piece attribute. If I say for each primitive, and I can create this for each primitive, color and random. Again, extract each point, color point primitive. Okay, you see what is happening here. I set it to points, so the color was going onto the points. So you see, now each primitive of this is getting this seed 0, and if I change the seed, you see our color is changing. What is happening? This color action is being performed on each primitive at a single time. So if I say when it is performing on the primitive 0, it is at seed 1, but at primitive 1 the iteration becomes 1. And we can do it, we can just do the iteration value, we can just do we can write the here that each iteration I want a different seed. And for this you have this detail attribute. So what we are doing, we are fetching the data from this detail. I created the Hscript video where we use the Hscript code, and this is the Hscript code that tells us like we fetch data from different levels of here. Like we are at point level, you can extract the data from points, and this detailed data I told you about, it tells you how many iterations you have, right? So you see iteration 0, and what we will do, we will put this iteration value which will be changing, by each iteration. It will go from 0 to this, so we will just change the seed from this data directly. And this code says first you want to give it like which node you are extracting this data from. So I will say for each begin to metadata, for each begin to metadata 1, and I will say I want to have iteration and 0. So you will see now each primitive have a different color. And what is this code? First you say where from which level we are extracting this detail from. Then you say the node path. This node is giving us the total number of iterations. And then you tell what type of parameter, what type of attribute, or what type of parameter you want, what type of attribute you want to extract from that node. So you are saying I want to extract the iteration, and this 0 means, you see you have this index numbers for each point, but detail you don't have any index number, so you just have to put here 0 also, 0 at the end, because this is just how the code works, this is the syntax. So you need to put 0, and if you are on primitive level, then you have to put which primitive you are extracting the data from. That's simple, I guess you can understand this. So now we have different colors on each primitive, and this is the way wherever you will learn this for each node, you will see these examples, right? This cheese thing was in the Houdini official data, and this color is the best way to to view this in action. And now we have this, what we can do, you see this color is happening, so that means seed is changing at each iterations, right? And now what I can do, I can delete this, or I can just duplicate it here, and you will see instead of color I will just use a transform node again, and I will just use this is the disintegration method. You can see it is the best way to see in action. So what you can do, I want to rotate, but at each iteration, that means if I'm at primitive 1, right, I want to rotate that primitive by some number, then when it will go to primitive 2, it will be rotated by by a certain amount, and it will be dependent on the iterations like we did with this. You can see a single pass also, you can see a single pass. So each iteration is giving you something, each iteration is working on each primitive, and each primitive is getting a different seed. That's we will do with this also. So I will just transform this, and I will put the same number here, I will put the same thing here, detail. So we are fetching this data from detail, and let's say I want this from for each begin metadata 2, for each begin metadata 2, and I want to have which attribute, oops, I want to have iteration and put 0, right? And you will see something, but we don't have by piece primitive and detail for each transition, metadata to iteration, detail for each. What I did wrong? For each piece of point, primitive, merge, single pass. Primitives, detail, and I want for each metadata to iteration 0. This, why this is giving me an error? Okay, we have something like this, and you see, I will do it again. I will just hit transform, and here transform, and I can just say I want this to be detail, and I want to fetch the data for each count 2, and I want to have iteration and 0. That's it. Iteration 0, and here I forgot to put these quotations, and you will see what is happening here. First I will just say iterations, right? I can create a null, connect it here, right? And I can create a new parameter float accept, and here I will just put it something like here, and I want to put copy parameter and paste relative reference. So you will see what is happening here. I just created this, right? And I multiplied it with this null channel, right? And I did the same, but here in this line, at each iteration, each primitive is rotating at like by a certain angle. And when you increase this, you will see our geometry is doing something like this. That means 0, that means no rotation. When you at 0.035, that means these primitives are rotating separately, right, by certain rotation. And you can have this disintegration effect, and when you can animate this, and you can, like, whatever you want, you can animate this and you can render this, and you will have this effect. So you see, we are performing this transform on each parameter. Let's make this, let's take this to one another level. So I was working with this, right? And we're here. So I will just copy this, or I can use this. I can create this whole setup again. So what I will do, I will just create for each number, and you will see I have this. I have this setup, right? And I will copy and paste it here, so I can put it right here. You see, I have this setup. So what is happening here in Wrangle? Just focus on this curve view offset. So when I increase the offset, you see this is working. So at the second iteration, I want a different offset, right? So what I can do, I can just first, I can create a null here, and I can put this in black, and I can say information, or I can say iterations. So this will give me iterations. And how it will give me iterations? I can just create a spare input, and I can create a float accept. So I can just put, I want to have the let's say detail and -1 and iteration and 0. So what will happen, this sphere input, if I say this, right? So this sphere input is now being connected to this for each end. This for each end will give you this detail. So I'm fetching this detail, and -1 here means sphere input 0, because 1, 2, 3, 4 are like predefined for like these points, 1, 2, 3 inputs. So we use -1 for 0, and if there is spare input 1, that means we will use -2 for that, and so on, so on. And we are just getting this iteration value. So we are right now at let's say at 0 iterations, and if I say single pass, you will see it will change. No, oh, why it doesn't change iterations for each? Not this, we want this. So if I increase the iterations for each detail, iteration 0, okay, I don't want this, and I definitely don't want this, so this will be here. And when I say, you will see we have at 0, still 0, then this single pass for each n iteration 0, but we are at iteration 3. Why this is not working? March, I have to look this up. For each count 4, for each, I just have to put it here. So now it is working. Now it is working. So I have to put this here, and it is working. Okay. So what we are doing, I'm fetching this data instead of writing this node whole detail thing, right? So instead of writing detail detail and everything, I'm just putting this here, and I'm just saying that just fetch the data from this. So instead of writing that whole detail and path, you can just use this. And what I can do now, I just have to put this and here in offset. So I will say detail, and I am fetching that data from I can say copy parameter, and I can just paste it right there. So chf. So you will see we will have something like, paste. I can say it's not working, right? So I can just paste relative reference and plus attribute time divided by 20. So this will give you this, and you will see something like this, or 10. So this is the setup that I just wanted to like tell you. So what I did, I just copied this and pasted into this, and I've created this channel. This was already existed, and I just did something like this. So we are rotating this around this axis by each iteration. So this is it for this video, and I hope you understand something about for each loop, and I will see you in the next one.